Have you ever wondered if the portals we see in science fiction movies could exist in real life? From the whimsical doorways of Doctor Who to the interdimensional rifts in Stranger Things, portals captivate our imagination and challenge our understanding of the universe. Yet, what if these fantastical elements are not as far-fetched as they seem? This essay explores the intriguing intersection between the creative world of science fiction and the rigorous discipline of scientific research, delving into the question, are portals science fiction, or could they be hidden science? The concept of a portal, a bridge connecting two distant points in space or even time, touches on some of the most profound theories in physics. Albert Einstein's theories of relativity opened the door, so to speak, to the possibility that the fabric of space-time could be manipulated or traversed in ways previously relegated to the realm of fiction. As we journey through the latest scientific insights, we will uncover how contemporary science is beginning to sketch the outlines of these seemingly magical structures. This exploration is not just a theoretical exercise. It is a quest that cuts to the heart of fundamental physics and our understanding of the universe. By comparing the portals of science fiction with the scientific theories and discoveries that hint at their possibility, we aim to inspire awe and wonder at the mysteries that science continues to unravel. Albert Einstein's theories of general relativity proposed that massive objects cause a distortion in space-time, which is now a fundamental principle in understanding the universe's structure. His equations suggested that under extreme conditions, space and time could contort enough to create phenomena resembling the portals seen in stories. These theoretical constructs are not mere flights of fancy, but are based on solid mathematical groundwork. Einstein's work led to the concept of wormholes, theoretical passages through spacetime that could connect two distant points in the universe. These are not actual physical tunnels, but rather solutions to the equations of general relativity. Think of them as a sort of cosmic shortcut that, in theory, could make interstellar travel or even time travel feasible under the right conditions. The science community continues to debate the stability and traversability of these wormholes, making them a hot topic of research. While Einstein himself never claimed that wormholes or portals were practically achievable, his theories make such ideas conceivable within the laws of physics. The next step for scientists is determining whether these theoretical pathways could exist naturally or be artificially created, and crucially, whether they could ever be stable enough for anything to travel through them without collapsing. Quantum mechanics introduces another layer to our understanding of potential portals. At its heart, quantum theory deals with probabilities and the behavior of particles at the smallest scales. Here, the rules of classical physics no longer apply, and particles can behave in strange and unexpected ways, such as being in two places at once. One of the most mind-bending concepts in quantum mechanics is the idea of quantum tunneling, where particles pass through barriers that, according to classical physics, should be impenetrable. This phenomenon is akin to a subatomic portal, where particles disappear from one location and instantaneously appear in another, bypassing the space in between. Such behaviors challenge our everyday experiences and perceptions of reality. Quantum mechanics may also contribute to the idea of wormholes. Some theorists suggest that if quantum effects could be scaled up, they might allow for the stabilization of wormholes that could be used as portals. This intersection of quantum mechanics and general relativity is a primary focus in the quest to understand if science fiction-like portals could ever become a scientific reality. The implications of such a discovery would be profound, affecting everything from computing to communication and beyond. Space missions and astronomical observations have occasionally provided anomalies that stir the imagination of both scientists and science fiction enthusiasts. These anomalies often raise questions about what might be lurking in the unseen corners of the universe. For instance, the behavior of black holes and the peculiar trajectories of galaxies suggest there are forces and phenomena at play that are not fully understood. The observation of high-energy cosmic rays also hints at potential natural portals. These rays possess energy levels so high that their source remains a mystery. One speculative theory suggests that these rays might originate from other universes or dimensions, potentially entering our own through portal-like passages. While this remains a hypothesis, It provides a tantalizing glimpse into the possibilities that lie in unexplored aspects of cosmology. Moreover, the study of dark matter and dark energy, substances that together comprise most of the universe's mass energy content but are not directly observable, suggests that our understanding of the cosmos is still in its infancy. The properties of these mysterious components could provide clues to the nature of space-time connections that resemble the portals of science fiction lore. The theoretical concept of a wormhole, or Einstein-Rosen bridge, is a fascinating consequence of Einstein's theory of relativity. Put simply, a wormhole could act as a bridge connecting two different points in space-time. In theory, if one could traverse this bridge, it would allow for shortcuts across the universe or possibly into different dimensions or times, much like the portals seen in science fiction narratives. The geometry of a wormhole involves a tunnel-like structure with two ends, each at separate points in space-time. For a wormhole to be useful as a portal, it would need to be traversable, which means it would have to be large enough and stable enough for matter to pass through without collapsing. Current theories suggest that exotic matter with negative energy density would be required to stabilize a wormhole, but such matter has not yet been discovered. The practical creation or discovery of a stable, traversable wormhole is beyond our current technological capabilities. However, the theoretical possibility continues to inspire researchers and fuels the narratives of many science fiction stories. Whether wormholes will ever become part of our reality remains one of the most intriguing questions in physics, and one that ensures the continued interest and funding of theoretical studies in this area. Quantum entanglement is one of the most peculiar aspects of quantum mechanics. When particles become entangled, the state of one, no matter how far away it is, instantly correlates with the state of the other. This phenomenon, sometimes described as spooky action at a distance by Einstein, hints at an invisible connection that transcends classical ideas of space and time. This concept of entanglement suggests a kind of information portal, where changes to one particle immediately affect its entangled counterpart, regardless of the distance separating them. This has profound implications for communication and computing, potentially allowing for the development of quantum computers and unbreakable quantum encryption. Such technologies could revolutionize how we transmit and secure information, effectively using quantum entanglement as a portal for instantaneous data exchange. While it's not a portal in the traditional sense of transporting matter, quantum entanglement challenges our understanding of how information can be transferred and manipulated. It also raises philosophical questions about the nature of reality and whether we might one day be able to harness these quantum connections for more than just information flow. Could these ethereal links lead us to a new understanding of the universe that aligns more closely with science fiction than we ever imagined? Despite the theoretical possibilities, the experimental evidence for portals remains elusive. However, that has not deterred the scientific community from searching. Recent experiments in particle physics and cosmology are designed to probe the edges of known physics and perhaps reveal portal-like phenomena. For instance, the Large Hadron Collider, LHC, at CERN conducts high-energy collisions that some theorists speculate might create microscopic black holes or wormholes. Furthermore, advancements in gravitational wave astronomy could potentially offer clues about the structure of space-time and its anomalies. The detection of gravitational waves was a landmark confirmation of a century-old prediction by Einstein and has opened a new window into observing cosmic events that were previously beyond our reach. These waves might one day help scientists detect the signatures of wormholes or other exotic topologies in the fabric of space-time. Additionally, other experimental setups like those attempting to detect dark matter might inadvertently stumble upon phenomena indicative of portals. The search for dark matter is not just about understanding what it is, but also about unraveling how it interacts with ordinary matter and gravity, potentially offering insights into unknown aspects of the universe that could bridge the gap between science fiction and reality. The influence of science fiction on scientific inquiry cannot be understated. Many of today's leading scientists grew up inspired by the fantastical possibilities depicted in books and movies. These narratives fuel curiosity and stretch the boundaries of what we believe is possible, often predicting or inspiring real scientific advancements. For instance, The concept of a communicative device that could see and speak with someone far away was once pure science fiction, seen in shows like Star Trek. Today, it's simply a video call. Science fiction also plays a crucial role in popularizing science, making complex theories accessible and exciting to the general public. This genre has the unique ability to simplify and dramatize scientific ideas, making them relatable and understandable. By framing scientific quests in terms of narratives and quests, science fiction connects emotionally with its audience, thereby fostering a deeper appreciation for science and its potential. Moreover, the dialogue between science fiction and science fact is a two-way street. While science fiction often anticipates or inspires technological innovations, scientific discoveries frequently provide new fodder for the narratives of science fiction. This interplay ensures that both fields continually evolve, with science fiction pushing the boundaries of what science considers and science continually expanding the horizons of what can be imagined. While the current scientific understanding and technological capabilities make the construction or discovery of portals as seen in science fiction a distant reality, the pursuit of such phenomena remains a vibrant field of study. The theories of relativity and quantum mechanics provide a framework where these fantastical elements do not seem entirely out of reach. As our tools and techniques improve, so too will our ability to probe the deeper mysteries of the universe. The future of portals, whether as practical pathways through space and time, or as theoretical constructs that challenge our understanding of physics, is an exciting frontier. It embodies the spirit of exploration and the relentless quest for knowledge that characterizes both science and science fiction. Whether or not portals become a reality, the journey of discovery will undoubtedly unveil aspects of the universe that are currently beyond our wildest imaginations. In conclusion, the fascinating overlap between the portals of science fiction and the emerging science of portals illustrates how imagination and inquiry drive each other forward. This dynamic interaction not only enriches our understanding but also keeps the flame of curiosity alive, ensuring that science, much like the stories it inspires, continues to be a thrilling adventure.